Is it visible, ma'am?
Yeah, ma'am, it's visible. Chapter 4, pair of straight lines.
Yes. Can I start now?
Start, madam.
Good evening to all. Today we are going to deal with the chapter 4 in 1B, that is pair of straight lines. It contains two 7 marks question, that total of 14 marks we will get from this in the IP exam. I am Usha Pente, PGT Maths from TSRS and JC Girls Pochampad. So 7 marks IPE important questions we will get. If theta is the angle between two straight lines represented by ax square plus 2hxy plus by square is equals to 0, then cos theta is equals to a plus b by under root of a minus b plus 4h square. We need to prove this. So for this, as a minus b plus 4h square is in the denominator, it should be is in the denominator and is under the root. So we have to consider that at any cost we need to take it as greater than 0. So next we are considering this equation. This is the standard form of second degree equation, that is ax square plus 2hxy plus by square is equals to 0 is the equation from the origin. That is equals to what we are, as it is representing the pair of straight lines. So we will write it as Lx plus my into L2x plus M2y. This implies what? If we multiply this one and we compare with the standard one, what we'll get? We'll get L1, L2 is equals to A, M1, M2 equals to B, and L1, M2 plus L2, M1 is equals to 2H we will get. Then the lines represented by the given pair of equations are L1x plus M1y equals to 0 and L2x plus M2y is equals to 0. This implies what? Here L1 is equals to A1, L2 is equals to A2, M1 is equals to B1, and M2 is equals to B2. Therefore, the angle theta between the lines is given by cos theta is equals to mod of A1 A2 plus B1 B2 by under root of A1 square plus B1 square into A2 square plus B2 square. Then if we substitute these values over here, then cos theta is equals to what? In place of A1, what we have L1. In place of A2, what we have L2. In place of B1, we have M1. And in place of B2, we have M2. So we are substituting that values in the given, in the cos theta formula. That is cos theta is equals to A1 A2 plus B1 B2 by under root of A1 square plus B1 square into A2 square plus B2 square. So what we'll get? We will get cos theta is equals to L1 L2 plus M1 L2 M2 by under root of L1 square plus M1 square into L2 square plus M2 square. Then next, what we'll get? When we multiply this, cos theta can be written as cos theta is equals to this numerator as it is we have written, and in the denominator we are multiplying the each term. L1 square into L2 square, that is L1 into L2 whole square will get. In the similar way, M1 square into M2 square will get M1 into M2 whole square plus L1 into M1, L1 into M2, that is L1 M2 whole square plus M1 into L2 whole square. Now, so in the denominator, we are adding and subtracting this 2L1, L2, M1, M2. So we are adding as well as subtracting 2L1, L2, M1, and M2. Then what we'll get? Cos theta is equals to L1, L2 plus M1, M2 by L1, L2 whole square plus M1, M2 whole square plus L1, M2 whole square plus M1, L2 whole square minus 2L1, L2, M1, M2 plus 2L1, L2, M1, M2. Now what we are doing? We are combining the terms in such a way that we should get a minus b whole square as well as a plus b whole square. So which terms we need to combine? We need to combine L1 L2 whole square plus M1 M2 whole square minus 2L1 L2 M1 M2. If we take together, it will be of the form a square plus b square minus 2ab. Then we'll get it as a minus b whole square. Here a is equals to L1 and L2 and b is equals to M1 M2. Hence we'll get L1 L2 minus M1 M2 whole square by combining these three terms, that is L1 L2 whole square plus M1 M2 whole square minus 2L1 L2 to M1 M2. If we combine these three terms, we'll get this L1 L2 minus M1 M2 whole square. Next, we are remained with these three terms, that is L1 M2 whole square plus M1 L2 whole square plus 2L1 L2 M1 M2. 2L1 L2 and M1 M2. So we will get that as it is in the form of a plus b whole square, that is a square plus b square plus 2ab. Hence we'll get it as L1 M2 plus M1 L2 whole square. Now we are substituted. Already we know that L1 L2 is equals to a and M1 M2 is equals to b and L1 M2 plus M1 L2 is equals to 2h. Hence we are substituting that values in this. So we will get it as cos theta is equals to a plus b by under root of a minus b whole square plus 2h whole square. That is nothing but cos theta is equals to a plus b by under root of a minus b whole square plus 4h whole square. Hence we have proved the angle between the pair of straight lines. So that is cos theta is equals to a plus b by under root of 1 a minus b whole square plus 4h square. Now the second one, that is show that the product of the perpendicular distances from point alpha comma beta to the pair of straight lines represented by ax square plus 2hxy plus by square is equals to 0 is a alpha square plus 2h alpha beta plus b beta by under root of a minus b whole square plus 4h square. So what we need to prove? We need to prove that the product of the perpendicular distance from a point, here the point given as alpha comma beta, to the pair of straight lines. The pair of straight lines represented by which one? That is this equation, that is ax square plus 2hxy plus by square is equals to 0. This is the equation of pair of straight lines passing to the origin. Is how much is this? That is a alpha square plus 2h alpha beta plus b beta square by under root of a minus b square plus 4h square. Now let us see what is the solution. Now we know how the pair of straight lines are represented in the form of this, that is a L1x plus M1y is equals to L2x plus M2y. Then the lines represented by the given pair of equations are the lines represented by the given pair of equations. What are the lines here we have? That is L1x plus M1y is equals to 0 and L2x plus M2y is equals to 0. Now, if you multiply these two, what we'll get? We'll get L1 L2 is equals to A, M1 M2 is equals to B, and L1 M2 plus L2 M1 is equals to 2H. Here, D1 is equals to what? D1 is nothing but the length of the perpendicular from a point. Here, the point is alpha comma beta to the line, that is L1x plus M1y is equals to 0. And we will get the length of the perpendicular as L1 alpha plus here in place plus M1 beta by under root of L1 square plus M1 square. We know that perpendicular length of the perpendicular to a line is given by ax1 plus by1 by under root of a square plus b square. Here we are using that formula, hence we are getting this one, that is L1. Here in place of a we have L1 and in place of x1 we have alpha x1 and y1 we have alpha and beta, while in the place of ax plus by we have L1x plus M1y is equals to 0. Hence we are getting this one, that is L1 alpha plus M1 beta by under root of L1 square plus M1 square. Now, D2 is nothing but the length of the perpendicular from the point to the other line. The other line is L2x plus M2y is equals to 0. We know the formula. We are substituting the values. So hence we'll get it as L2 alpha plus M2 beta by under root of L2 square plus M2 square. As they are asking for the product of the perpendicular, so then product of the length of the perpendicular from the given point to the given pair of lines is given by D1 into D2 is equals to what? Here D1 is equals to L1 alpha plus M1 beta by under root of L1 square plus M1 square, and D2 is equals to L2 alpha plus M2 beta by under root of L2 square plus M2 square. Now we are writing this one. That is L1 alpha plus M1 beta into L2 alpha plus M2 beta by L1 square plus L2 square into M1 square minus plus M2 square. That is equals to, when we multiply these two, we will get and take an alpha square common. That is alpha square is A in L1, L2. In place of L1, L2, we have A, that is A alpha square plus, in place of B1, L1, M2 plus L2, M1, we have 2H. So we are taking 2H alpha beta plus M1, M2, we will take it as B beta by under root of what? Under root of A minus B whole square plus 4H square. Show that the area of the triangle formed by the lines ax square plus 2hxy plus by square is equals to 0 and lx plus my plus n is equals to 0 is how much? N square under root of h square minus ab by an square minus 2hlm plus bl square. So we need to show that with the pair of the lines, straight lines, pair of the straight lines and the given line, it forms a triangle, and the area of that triangle is nothing but n square into under root of h square minus ab by an square minus 2h lm plus bl square. So here what they have given a pair of lines and another line. So we have taken x-axis and a y-axis. So the intersection of x and y-axis is nothing but O here. And we have taken a pair of lines. This is another line. Pair of lines is represented by ax square plus 2hxy plus by square. And this line is lx plus my plus n. And the intersection of this point is taken as A, that is x1, y1. And intersection of these two points and intersection of these two lines are taken as a point P, and it is represented as x2 and y2. Now, OA and OB be the pair of lines represented by the equation ax square plus 2hxy plus by square is equals to 0, and this AB is equals, AB be the line lx plus my plus n is equals to 0. So pair of this equation is represented by these two pair of lines, that is OA and OB, and this is represented by the line lx plus my plus n is equals to 0 is represented by the line AB. Let ax square plus 2hxy plus by square is equals to what? These two lines, that is L1x plus M1y into L2x plus M2y, and OA and OB be the lines Lx plus M1y is equals to 0 and L2x plus M2y is equals to 0 respectively. Now, let A1 is equals to which one we are taking? X1 and Y1. B1 is equals to X2 comma Y2. Then A lies here. A is lying on both the lines, that is OA as well as on AB. That is L1x plus M1y is equals to 0 and Lx1 plus M1y1 plus N is equals to 0. Since by the hypothesis in the given what they have, the three lines form a triangle. The three lines are forming a triangle. Then L1x, L1m minus LM1 is not equals to 0 and L2m minus LM2 is not equals to 0. So by the rule of cross multiplication, what we obtain? We obtain x1 by m1 m1 n is equals to y1 by minus n into L1 is equals to 1 by L1m minus LM1, and hence what we'll get, x1 is equals to m1 by cross multiplying m1 into n by this one, that is L1m minus LM1, and y1 is equals to minus n into L1 by L1m minus LM1. Similarly, in this x2 is equals to what? m2n by L2m minus LM2, and y2 is equals to minus L2 by L2m minus LM2. Therefore, we know the formula for the area of a triangle. Area of the triangle, if the 2 points are given, then what is the area of the triangle? We can find the area of the triangle OAB by half into mod of x1 into y2 minus y2 into x1, x2 into y1. That is, we are substituting the values. Half into mod of n square into L1m2 minus L2m1 by L1m minus LM1 into L2m minus LM2. Now, we are writing this as the form of a minus b whole square can be written as a plus b whole square minus 4ab. In the similar way, a minus b can be written as under root of a plus b whole square minus 4ab. So we are using here, we are using that one and we are writing this one. That is half into n square into a minus b can be written as under root of a plus b whole square minus 4ab. That is, here a is equals to L1m2 and b is equals to what? L2m1. Hence, we are taking this terms. That is L1m2 plus L2m1 whole square minus 4 L1 L2 m1 m2 by, now multiplying the denominators, terms in the denominators, that is L1 into m into L2 into m is equals to L1 into L2 into m square minus L, that is Lm into L1 m2 plus L2 m1 plus m1 m2 into L square. Hence, we will get half into n square into, here what we have, this can be written as 2h, already we have seen before, that is 2h square. 2h square is nothing but 4h square minus 4 into ab by L1 into L2 is nothing but a, hence we are substituting that value a into n square minus this value is nothing but 2h and minus 2h Lm plus this m into m1 into m2 is nothing but b, therefore b into L square. Hence we are getting this. From this we will take a 4 under root of 4, that is 2, we will take common and we will cancel it. That is 2 in the denominator and 2 in the numerator are cancelled, and we are left with n square into under root of h square minus ab by a n square minus 2h Lm plus bl square, which is the area of the triangle formed by the pair of straight lines and the line, and it is given by n square into that one. Next problem. Show that the lines represented by Lx plus my whole square minus 3 into mx minus ly whole square is equals to 0 and Lx plus my plus n is equals to 0 form an equilateral triangle with area n square by under root 3 into L square plus n square. So what they have given? They have given a, instead of the form that is ax square plus 2hxy plus by square, they have given this one, that is Lx plus my minus 3 into mx minus ly whole square is equal to 0, and the line, pair of straight line and a line, and they are asking that it forms a triangle. What kind of triangle it is formed? It is formed an equilateral triangle, and area of that equilateral triangle is n square by under root 3 into l square plus m square. Now, this is the given pair of lines. This is the equation for the given pair of lines. And we are taking it as equation 1. That is Lx plus my whole square minus 3 into mx minus ly whole square is equals to 0. We are considering the given equation as equation 1. Now, this is in the form of Lx plus my. It is in the form of a plus b whole square. So we are expanding it. That is, a plus b whole square can be written as a square plus b square plus 2ab. And it is this mx minus ly is in the form of a minus b whole square. And we know the formula for a minus b whole square. That is a square plus b square minus 2ab. Hence, we are expanding. Using that formulas, we are expanding these two terms. Therefore, what we'll get it as Lx whole square plus my whole square plus 2 into Lx into my minus 3 into what we have over here, that is mx whole square plus ly lm xy. That is L square x square plus n square y square plus 2lx my minus, if we multiply 3 inside, that is minus 3 into m square x square, plus of minus is minus 3l square y square, minus of minus will become plus, 3 times of 2 is 6, lm xy is equals to 0. Hence, we can write it as L square, means getting all the like terms together, that is L square x square minus 3 into n square y square plus n square x square plus n square y square minus 3l square y square plus here what we have 2l x and y and 6l m x y. Therefore, if we add these two terms, what we'll get plus 8l m x y is equals to 0. Now,
Hello.
ma'am.
Your screen is not visible, ma'am.
Screen visible లేదా? Now, ma'am, is it visible
Yes,
now?
ma'am, it is visible now.
Okay. Okay, this is the fourth sum, that is show that the lines represented by Lx plus my whole square minus 3 into Lx minus mx minus ly whole square is equals to 0 and Lx plus my plus n is equals to 0 form an equilateral triangle with this area n square by under root 3 into L square plus n square. That is, this is the pair of lines that they have given, and it is this is Lx plus my square minus 3 into mx minus Ly whole square is equals to 0, and this is the line they have given. And with these pair of straight lines and the line, it forms an triangle, and the triangle is a equilateral triangle, and area of that equilateral triangle is n square by under root 3 into L square plus n square. So we have taken the given equation of pair of lines, that is Lx plus my whole square minus 3 into Lx minus Ly square is equals to 0, and we are taking it as equation 1. Now we are expanding this one, that is by using the formula a plus b whole square, and this by using the formula a minus b whole square. A minus b whole square is a square plus b square minus 2ab, and a plus b whole square is a square plus b square plus 2ab. Now we are expanding the terms, that is here a is equals to Lx and b is equals to my. That is Lx whole square plus my whole square plus 2 into Lx into my minus 3 into here a is equals to mx while b is equals to Ly. That is mx whole square plus Ly whole square minus 2 into mx into Ly is equals to 0. Now we are, as we have a square, that is L square x square plus n square y square plus 2lx my minus 3 into m square x square plus L square y square minus 2l mx 2lm xy is equals to 0. That is L square x square plus n square y square plus 2lx my minus multiplying 3 inside. So minus 3 into n square x square minus 3l square y square plus 6lm xy is equals to 0. Now getting all the like terms together. So L square x square minus 3 n square x square plus y square terms, that is m square y square minus 3l square y square plus 2lx my plus 6lx my can be written as 8lm xy is equals to 0. Now we are taking from these two terms, we are taking common x square, that is L square minus 3n square into x square plus n square minus 3l square into y square plus 8lm xy is equals to 0. Now we are comparing this equation with the standard form, that is ax square plus 2hxy plus by square is equals to 0, where a is equals to how much? L square minus 3n square, and b is equals to n square minus 3l square, and 2h is equals to 8lm. We know the angle between the pair of lines is given by cos theta is equals to a plus b by under mod of a plus b by under root of a minus b plus 4h square. Therefore, cos theta is equals to what? In place of a, we have L square minus 3n square plus b is equals to n square minus 3l square by under root of, in place of a, we have L square minus 3n square minus b. B is m square minus 3l square whole square plus 4h square, that is a 2h 4h square can be written as 2h whole square. Here 2h is lm whole square. Lm whole square is nothing but 8 square is 64 l square n square, and cos theta is equals to L here. When we simplify this, L square minus 3l square can be written as minus 2l square, and minus 3n square plus n square can be written as minus 2n square by under root of, here we will take it as, if we take consider minus, if we take minus inside, then L square minus 3n square minus 3n square minus of minus will become plus 3l square whole square plus 64 l square n square. So minus 2 into L square plus n square by
Can you go for slideshow, please?
from first, I think so. Okay. Equals to mod of minus 2l square plus n square by under root of 4l square minus 4n square whole square plus 64l square n square. That is equals to minus 2 L square plus n square. From the this under root, we have taken 4 square common from this term. So we'll get 4 square common, and we can write it as L square minus N square whole square plus 64 L square N square. Mod, if we take a mod of a negative is nothing but positive. So we are taking out of mod and we are writing it as 2 into L square plus N square by under root of 4 square can be written as 16 L square minus N square whole square plus 64 L square N square, and 2 into L square plus N square by 16 into L square plus N square whole square plus this one can be written as 4 square 4 into, as we are taking 16 common, so 16 fours are 64, so 4 L square N square. That is 2 into L square plus N square by 16 into L square plus N square whole square plus 4 L square N square. If you take out that 4, that is under root of 16 is nothing. If it comes out, we will get it as 4. So 4 under root of, this can be written as a minus b whole square. Therefore, L to the power of L square whole square is L to the power of 4. M square whole square is M to the power of 4 plus M to the power of 4 minus 2 into L square plus M square plus 4 L square M square. That is L square plus N square. This will get cancelled. That is, in the numerator we have 2, in the denominator we have 4. That is 2 times 1 and 2 times 2. That is, we will get it as L square plus N square by 2 into under root of L to the power of 4 can be written as L square whole square. M to the power of 4 can be written as N square whole square. If we simplify this, we will get it as plus 2 L square N square. And it is in the form of A plus B, A square plus B square plus 2AB. It is in the form of A square plus B square plus 2AB. That is nothing but A plus B whole square. That is L square plus N square by 2 into under root of L square plus N square whole square. And the given line is this one. That is Lx plus My square minus 3 into Mx minus Ly square is equals to 0. And it can also be written as, this 3 can be written as under root 3 whole square. So we are taking this one as under root 3 whole square. That is Lx plus My whole square minus under root 3 into Mx minus Xy, Mx minus Ly whole square is equals to 0. That is Lx plus My plus this one. That is, it is in the form of A square minus B square is equals to 0. We know that A square minus B square can be represented as A plus B into A minus B. Hence, we are taking these terms as, here we are considering A is equals to Lx plus My, while B is equals to under root 3 into Mx minus Ly. Therefore, Lx plus My plus under root 3 into Mx minus Ly and Lx plus My minus under root 3 into Mx minus Ly is equals to 0. Now, Lx, we are multiplying this under root 3 inside and we are writing this term as it is Lx plus My plus under root 3 into Mx can be written as under root 3 into Mx. Plus of minus is minus, so minus under root 3 into Ly. In the similar way, this one also we are taking, that is L1 plus Lx plus My as it is, and we are multiplying minus root 3 inside. Therefore, minus into plus is minus, root 3 into Mx is root 3 Mx, minus of minus is, we'll get it as plus root 3 Ly. Therefore, we are getting Lx plus under root 3 into Mx plus My minus under root 3 into Ly. That is, we are taking the x terms and the y terms together. Lx minus under root 3 into Lx plus My minus under root 3 into Ly. So, if we take x common from the first two terms, we'll get L plus under root 3m. And if we take y common from the next two terms, we'll get m minus root 3 into L into y. From the first two terms, we are taking x common. So L minus under root 3 into x, under root 3m into x. And from the next two terms, we are taking y common, m minus under root 3 into L y is equals to 0. Hence, so we are splitting these two equations as, that is 1 minus under root 3 m plus m plus under root 3 L y is equals to equation 2, and 1 plus under root 3 m into x plus m minus under root 3 into 1 y is equals to 0 as equation 3. And the given line is Lx plus my plus n is equals to 0, and we give this equation as equation 4. Now the angle between the equation 2 and equation 4 is given by, we know that the angle between the two straight lines is given by the cos theta is equals to mod of a1 a2 plus b1 b2 by under root of a1 square plus b1 square plus into under root of a2 square plus b2 square. So now we are comparing equation 2 with a1x plus b1y plus c1 is equals to 0. We'll get a1 is equals to 1 L minus under root 3m and b1 is equals to m minus under root 3L. Now we are comparing equation 4 with a2x plus b2y plus c2 is equals to 0, and we will get a2 is equals to L and b2 is equals to m. Now we are substituting that values in the formula, that is cos theta is equals to, in place of a1 we have 1 minus 2 3 into m, and a2 we have L plus. In place of b1 we have m minus m plus under root 3 into L into m by 1 minus under root 3 into m whole square plus m into under root 3L whole square into under root L square plus m square. That is cos theta is equals to L square minus under root 3 Lm plus m square plus under root 3 Lm by under root of L square plus 3 m square minus 2 root 3 Lm 3L square plus n square plus 2 root 3 Lm, and it is under root of L square plus n square. That is cos theta is equals to L square plus n square by under root of 4L square plus 4n square into under root of L square plus n square. That is cos theta is equals to L square plus n square. If we take 4 common, we'll get under root 4 is nothing but 2. So we are getting 2 outside. That is 2 into under root of L square plus n square into L square plus n square. Now in the numerator we have L square plus n. In the denominator we have what? L square plus n square into L square plus n square will get is L square plus n square whole square. The under root of L square plus n square and root gets cancelled. We'll get L square plus n square by 2 into L square plus n square. If we cancel L square plus m square, and in the denominator if we cancel L square plus m square, these two terms gets cancelled, will remain with 1 by 2. That is cos theta is equals to 1 by 2. What does this imply? This implies that cos theta, when we'll get a half, that is cos 60 is nothing but 1 by 2. Therefore, we'll get cos theta is equals to, this implies that theta is equals to 60 degrees. Now we are finding the angle between the equation 3 and equation 4. The sum of the angles in a triangle is 180 degrees. Theta is equals to 180 minus this 60 and 60. Will get what? 180 minus 120 minus 2 minus 120. That is 2 minus signs at that 60 plus 60 plus 60 is 120. So minus 2, 120 degrees. 180 minus 120 is 60 degrees. Therefore, the three angles are 60 degrees, 60 and 60. We know that the equation, the definition of a equilateral triangle, if the three angles are equal, then we can call that if three angles of a triangle are equal, we call that triangle as an equilateral triangle. Hence, we have proved that the given lines form an equilateral triangle. Now, let P is equals to length of the perpendicular from origin to the line, that is Lx plus My plus n is equals to 0 is equals to P square by under root 3. That is equals to n by under root of L square plus n square. That is the area of the equilateral triangle is, here P is equals to, that is n by under root of L square plus n square by under root 3. That is equals to n square by under root 3 into L square plus n square. So you all have to practice this. You have to do it as take it as a homework. This sum show that the lines represented by this, that is 3x square plus 48xy plus 33y square is equals to 0, and 3x minus 2y plus 13 is equals to 0 form an equilateral triangle of area 3 by under root 3 square units. 3 by under root 3 square units. So this is the homework you have to do all. Thank you for the session.